Alright, I'm going to talking about the network tool modification assignment that I had and explaining it. So there is couple of modification that have been going on is the function, activation function, regularization, and rub out rate. So I will go along the line with the code. So first of all is the cost function. Cross entropy cost has been implemented, so there is no need to modify um, so there are two cost function that I have to work on is the cross entropy cost and the log livelihood cost. So here is the cross entropy with the function and the derivative. Log livelihood, one thing special about it is the zero value, so I have to work along with it to be able. So I got the function of the log livelihood and the derivative. Then the activation function is the sigmoid, softmax, uh, done and ReLU. So for the sigmoid is already provided. Softmax, I write out the function. Derivative is already there since the professor helped us in working on the softmax derivative. So it's related to dimension. Next is it done. I work on the function and also the derivative. And here A is the class function for the first one for the function z, then return by one subtract for the a power 2. For ReLU is a little bit special since the value is greater than 0, so that's why I have the function is the maximum of is a numpy maximum of it, and then the derivative is the heavy side of it, since whether to check whether z is greater than 0, equal 0, or less than 0, then it's gonna be have a different derivative. Now I'm talking about inside the network. First of all is the init function. Init function has and the set parameters function are very similar. So I do the modification very similar to for the bot function. So one thing I point out right here is the done. So I checked since if the output is done, then the cost function supposedly must be quadratic cost, and it's one of the not right here that professor has. So I make the condition if the activation output is done and the cost is not quadratic cost, then the activation output gonna be go back to sigmoid again. Uh, right here I make a modification for rub out, since rub out is the parameter of the set parameters and the init. So that's why I put the modification modify I make the condition of rub out right here. So if the rub out percentage is not 0, then the rub out is equal to, then the function of rub out activated with the rub mask right here. uh Next, go along a line. I don't make any modification on the weight initial or large weight either, but the feed forward is. So for the feed forward since we had the activation hidden and activation output, so the feed forward gonna be different. So the count right here I make right here is counting the layer. So if the count is less than the length of pi r subtract for 1, which is the output, so which is the input, so the feed forward gonna be have the function of the activation hidden, and else it's gonna have the activation output function right here. If the dropout is true, then the activation gonna time with the drop mask, and the count right here is subtract for true because it's gonna be backward. Then it's gonna be return the feed forward. There's no so there's uh not much of a modification for the SGD since it's going to export the output. So uh but there is a modification for the update mini batch. For the update mini batch, there is two big thing I put in is the rub out and the regularization. So for rub out, the hidden for the rub out, we had the B is the self rub out percentage, and then when we had that rub out percentage, we're gonna have the hidden layer is gonna be in the size because the hidden is the hidden layer, and size right here is the number of hidden layer subtract for the input. So I have the rub is going to be equal to the random number between 0 and 1, a binomial, and it's gonna be in the size of hidden, then divide for the rub up percentage. Then I have the rub mask is gonna be appended. Is rub mask gonna be appending each individual layer that contain the mask. For the regularization, it's gonna be between the option of L1 and L2. So with the L2, we're gonna have this way, for this calculation for weight, update weight, and for L1 we have a different calculation. The bias not gonna be affected. For back probe is also be affecting with the rub out, and also not only that but also the activation hidden and activation output. So similar to the feed forward, I have cow equals 0. So if cow is less than the length of bias, subtract 1, then we have the activation equal to the act hidden function. And if it's the rub out, it's gonna be have to time with the rub mask. And then at the end, the activation of output gonna be using the activation output. Next is the total cost, which is the last function that I am doing the modification. Is because since the total cost related to regularization, so that's why it has whether the option of shell of regularization is L1 or L2, then we have the cost different. So I also do, so I want to show you a little bit about the result I had. So for example, result number 2 is a little bit backward between the training test and testing test correct. So this is the test correct. It's 18, 44, 54. The test error is the same, and then the training error, the correct is 33, 69, 92. With the training error is 1.86 at first. Is similar. Let's try another one. Is the result 8. Result 8 is let's see, result 5, 6, 7, 8 right here. Right here I had. So is the training correct is 33, 33, 33 along the way with 1.56, and test correct is 17, and then the test error is 1.644. That's also correct. So checking on the result number 9. Result number 9, so we need to rewrite the kernel, so and I did. So here is the training error is, you see the training error is 30, 31, 62, 62, 74 at the end. It is the same training error. The test correct is 18, 20. Here is also correct. The test error is also similar. Then let's check for the maybe number 11 for the dropout. So dropout, we had the test correct is 17, 17. There is a little bit of different. However, the test error is very similar and it's very close. So which it caused the difference due to the dropout percent, the dropout random. So the training error is also very similar with 0.3336, 0.33 for the training error. So that's all I want to talk about for today and explaining about the code. So if you have any question, please let me know. Thank you.